Let's do some maths. Let's continue on with what we were working on before. We plotted sine x quite roughly off of the unit circle. Let's see if we can do the same with cosine of x. I'll begin with drawing something resembling the unit circle down here, and we'll have our y-axis, our x-axis across here. We'll draw the unit circle on. Now, it's a pretty rough old circle. Wow, is it ever? Minus 1, 1, 1, minus 1. Okay, so circle, radius 1, centered at the origin. Now, let's set up a set of axes so that we can draw cos and draw the x-axis across there. Here's our y-axis. Now, let's just go back here as we did for sine and just note that when we're measuring cos, I'll just put an arbitrary point on this circle, so say somewhere up here as I did before, and there's the coordinate xy, and we measure cos from the x coordinate. So this will be cos theta, and theta of course is the angle off of the positive x-axis. Okay, now again over here we don't want to plot the theta, we're plotting x along this axis. Okay, the x over here is equivalent to the theta over here. Okay, so I'll just make a note of that as I did before. So that'll be theta over here, that theta along here. So we're calling it x now. Okay, so let's begin when theta equals 0. So x is 0 over here. And what is cos 0? Well, cos 0 is 1. Okay, so cos 0 is 1. If we go out a little bit further, let's go say round to pi. Okay, so cos pi is negative 1. So we'll mark on here where pi is. So let's keep it in line with this graph up here. So this is our pi, and cos is at negative 1. So down here, let's just mark that on the axis. So we have 1, and down here we have negative 1. Okay, the value of cos at 2 pi is the same as cos 0, which is 1. Okay, so I'll mark on here 2 pi, so it's going to be 2 lots of pi. And again, cos here is 1. Okay, so let's go and do the angles halfway in between, or one angle halfway between 0 and pi. So pi on 2, we'll mark that on here. It's halfway between 0 and pi. So there's pi on 2. And what is cosine of pi on 2? Well, if you have a look at your unit circle, it's 0. So cos will be right here at pi on 2. The y value will be 0. Okay, and just a note that we're actually doing a graph of cos x. Okay, and also note that our x is in radians as it was for sine. Now, let's try halfway between pi and 2 pi, which will be 3 pi on 2. And cos 3 pi on 2, right around here, will be 0. Okay, so we've got a very rough shape. It looks V-shaped. But if we were to plot other angles like pi on 4, which would be 1 on root 2, pi on 6, pi on 3, we'd actually get a shape that's roughly like this for cosine. Yep, that is a bit rough. Okay, and just to note that what we see there is one cycle of cos. Okay, and of course cos, we can just rubber stamp that all the way down here and all the way up here, and cos just repeats, just like sine does. And of course that will cut through at minus pi on 2. And there it is, there's your cos. I suppose we should talk about the domain and range. Again, there's nothing that's going to upset cosine. You can put any number you want into cosine and it will give you a value. So the domain of cos is any real number, okay? And the range of cos, well, we'll have a look at the y values. It's only going to output between -1 and 1. Okay, there's no way we're going to get a 2 or a 3 or a -5 out of cos, just the same as for sine. So the range of cos will in fact be the same as the range for sine, which will be any number we like between -1 and 1 inclusive. Okay, and we can write that as a set. So the set of all y's, which we're taking from the real numbers, with the restriction that -1 is less than or equal to y, which is less than or equal to 1. There we have it. Just one more interesting thing. Note something, that if we were to take cos and shift it by this much, we would actually end up with sine. And if we took sine and just look at the top here and shifted it by this much, we'd end up with cos. So if we take the sine, if we shifted it to the left by that much, which is pi on 2, that's cos. So I might just put that down the bottom here, that if we take sine x, shift it to the left by pi on 2, then we end up with cos x. And also, the reverse, if we take cosine of x, cos x, and we shift it to the right by this much here, we'll end up with sine x. So we'll take cos x, shift it to the right by pi on 2, which is this much here, we're going to get sine x. And, whoops, I'll just move that up a bit so you can see it. And we're done. Thank you for watching.